Hi, this is Chong. High fidelity simulations with medical ventilator is technically challenging. Its technical complexity begins before the planning of scenario. This video focuses on common technical obstacles among manikin-ventilator simulations, and this is Technical 101 for manikin-ventilator simulations. This video is dedicated for SimOps who supports mannequins ventilator simulations or need to bridge mannequins with ventilator. For topics related to clinical mechanical ventilations, please visit other relevant sites. I've grouped these technical challenges in gases, connectors, pressure, mannequins, and ventilator, specifically invasive positive pressure ventilation, IPPV. In view of local regulation, these are the gas sensors indicate that facility is built with gases supply. These are the gases sensor, alarm, and switch. If you see these sensors in a simulations lab, likelihood that you are having actual 100% oxygen, 21% FiO2 of medical air, and minimum disruptions from ventilators inbuilt gas sensors. Compressor is an alternative in many simulation facilities. However, technical issues of compressor are noise, condensations, and low fractions of inspiration oxygen. Specifically, low oxygen concentrations lead to ventilator alarms and ruin the immersive learning environment. Reason being, ventilator can reject compressed air due to its oxygen concentrations below 21%. A simulation solution is to manipulate the oxygen sensor of the sim facility's own ventilator. Most importantly, do not alter oxygen sensor for any patient use ventilators to avoid clinical human errors. In contrast, not all mannequin tolerate 100% oxygen due to safety concerns. Connectors. Connectors come with different shape, colors, and grade. Match it with your needs, otherwise adapter may be required provided it is legal. Ventilator receives pressurized gas upon gas nozzle connects to the appropriate port. With local legislations, these gas nozzles are not interchangeable. Pressure is required for ventilation operations. Pressure drop leads to cease of ventilatory supports and alarms. Mannequins and ventilators. Mannequins' technical limitations, high oxygen concentrations, mannequins can't consume oxygen, and oxygen's accumulation is risky. Do refer to mannequin user manual. Carbon dioxide productions. Mannequin can't produce carbon dioxide or pulsatile CO2 for pathological capnography waveforms. Positive and expiratory pressures. PEEP confuse mannequin with breathing sensors, as mannequin may take it as incomplete exhalations. More limitations. Closed ventilation circuit. A closed ventilation circuit is required to allow positive pressure ventilations. In addition, inhale tidal volume has to be equivalent to exhale tidal volume. Otherwise, clinicians or ventilator interpret it as a circuit leak. Strong inspiration efforts. Mannequin's inspiration efforts has to be above ventilator's trigger threshold to activate each breath. Inspiration, airway resistance, and lung compliance maneuver. Breathing style variations occurs with disease progress. This maneuver facilitates ventilation's fatalities. Mannequin ventilation interactions or synchronizations or noise. Ventilation's interaction is a very challenging technical topic in simulations. Let's have a brief overview here and maybe a separate video for this topic. Ventilators. Pre-function tests and preventive maintenance are the most significant practice to minimize ventilation noise that interrupt these simulations. Others ventilator requirements are optional. For instance, visual outputs. Learner often obstruct ventilators as ventilation adjustment is taking place. Feeding the ventilation's graphic into the audio-visual system aids simulation observations and speed up the necessary parameters response. Gas sensor switch. As mentioned earlier, it is a plus point for facility with no medical gases supply. Simple ventilatory circuits and portable compressor. Pre-simulation function tests. They are simulations running with no prior check of simulator. Technically, ventilator pre-use functions test is mandatory prior to patient use. Note the difference findings between these pre-function tests. This dissimilarity will impact on ventilation's parameters and waveform. For instance, numbers of elbow joints, length, material and design of ventilation circuit, manikin's lung configurations skew the characteristic of ventilated breath, hence affecting the manikin's ventilator interactions unintentionally. From simulation's technical perspective, the practice of pre-use tests reduces the technical noise. Therefore, routine function tests and annual engineer reviews reduce disruptions to the ventilator functionalities in simulation. Alright, that's all for today. Let me know if this video is helpful for your simulations. See you in next video. Bye bye.